From the driver's seat, it may seem that not much has changed with a car over the past 50 years or so. Sure, there may be digital speedometers, heads-up displays, and certainly more accurate guidance systems. But looking through the windshield and the steering wheel, it all looks pretty much exactly the same as it did in the past. Behind the scenes, it's a different story, one your customers may not expect or understand. Historically, steering systems on cars were hydraulic. They utilized a pump to move the fluid to the power assist, either a steering gear or a rack and pinion. This pump was driven by the vehicle's engine and usually via a belt. This was only an assist, and the driver was moving the wheels. Today, the driver still has control of the vehicle, but the assist is coming from an electrical source. To understand the basic EPAS system, it is important to know the three basic types. The first is a column mount system. As you might expect, this type mounts the assisting assembly to the column. The column-mounted EPAS uses an electric motor on the steering shaft to assist when turning the steering wheel. This design has the benefit of keeping the electrical components inside the vehicle and out of the elements. Unfortunately, mechanical repairs to these components can require disassembly of the instrument panel, the dashboard, and other systems. The second type of system is an electrical hydraulic type of assist. The basic design is similar to the belt-driven hydraulic power steering pump systems, but the big difference is that it isn't driven by the vehicle engine power. It utilizes an electric motor to drive the pump impeller. The final type of assist is an electric rack and pinion system, which actually comes in four basic categories. The concentric or axial driven units integrate the motor into the rack, and the armature drives a screw-driven shaft that moves the rack back and forth. The belt-driven style uses an electric motor and a belt to drive the movement. The final two utilize motor-driven pinions, either driving the rack input shaft on a single pinion design or driving the rack bar shaft on a dual pinion design. Regardless of which type of system your customer has concerns with, it's likely that your investigation will involve sensors at some point. The first sensor is the steering wheel position sensor. The system needs to know which way the driver is steering the vehicle. The system utilizes the steering wheel position sensor to read the intended direction. EPAS systems use the speed sensor data from the anti-lock brake system to indicate rotational speed of the wheels. There is a torque sensor in these systems that tells the steering to assist the amount of torque a driver is putting on the steering wheel. The combined information from the speed sensor and the torque sensor allows the system to calculate how much assist to give the steering system. EPAS systems may also use a dynamic sensor. This sensor indicates vehicle movement and direction of actual travel. This allows the vehicle to utilize braking, throttle, and in some cases, low-effort steering assist to correct differences in steering direction against actual travel direction. More complex systems may present your customers with higher than expected repair bills. Your understanding and explanation of power steering system operation will help eliminate their uncertainty and assist you in better customer satisfaction. That's all for today. Thank you for being with us, and have a great day.